Alrighty, so let's take a minute to run through this one. Apparently changed this problem and forgot to update the answer key. So here we go. So the toy chest problem. So we've got this toy chest and this kid is going to pull it. Tells you that the toys and the chest combined have a combined weight of 180 newtons. Gives you the coefficient of static friction. It's just 0.3. So then in part A, it says the angle is 42 degrees and it wants to know what's the magnitude of the force the kid has to exert on the rope to just put it on the verge of moving, right? So the idea, I guess, is, so here's the ground and the box, and the kid is going to pull this way, right? But we need to split that into components, right? So let's just use F to be the force of the kid, okay? So that's going to have two components. That kid is going to be pulling in the X direction and he's going to be pulling in the Y direction. And that's what we're looking for, right? Is that force, F. So we want to write all of our components in terms of that. So the problem tells us that the force F is being exerted at an angle of 42 degrees. So that means that our Y component is F times the sine of 42. So let's figure out what that is. Sine of 42 gives us like 0.67. So this is 0.67 F. And our X component similarly is going to be F times the cosine of 42. And the cosine of 42 is 0.743. Okay. If you're interested, well, no, you don't care. All right, so there we go. All right, so now that we know that, let's go back to our drawing here. Well, here, first of all, let me move this out of the way because I don't think we're going to need that again. All right, so then let's see, we've got a gravity. We know that the force of gravity is going to be 180 newtons. I guess I should have filled in these numbers. This Fx is 0.743 F, and this is it was really like 669, which I rounded up to 0.67 F. All right. And then we have to have a normal force, but we know that our net force vertically has to be 0, right? And so what that means is that our normal force is just going to be big enough so that the normal force and Fy cancel out Fg. So this has to be 180 minus Fy. All right, and then we've got friction, right? So our friction, sorry, I've got these pens set to be too thick. So our force of friction is going to be negative, just this times 0.3. So it's negative 54 minus, I guess plus 0.2 F. Cool. So, you know what? I usually do magnitude. Hold on, let me rewind. I don't like this. So our force of friction should be this times 0.3, which gives you 54 minus 0.2 F. I like that better. Okay. Now, in order for it to move, then this guy needs to be bigger than this guy, right? So, we need Fx to be bigger than or equal to Ff. So 0.743 F is bigger than or equal to 54 minus 0.2 F. So add 0.2 F, you get 0.943 F is bigger than or equal to 54, and then solve. And your force turns out to be, it's like 57.3 newtons. Okay. So that is part A. Now, part B says, write an expression for the magnitude F required to put the chest on the verge of moving as a function of the angle theta. So now it's asking us to do the same thing, but in generic terms, right? So let's go back and look at the work that we did here. I'm going to kind of clean this up a little bit to make some room. So the idea is, if our angle changes, that's going to change these X and Y components, right? But regardless, what's going to happen is, based on that triangle that I just erased for some dumb reason, this x component is always going to be f times the cosine of theta, and this is going to be f times the sine of theta, right? Oh, well, that means then that my normal force here is going to be 180 minus f sine theta, right? So that this and this cancel out this. And then finally, my friction is going to be this times 0.3. So 54 minus 0.3 sine theta times f. So to get it on the verge of moving, once again, we need our fx to be bigger than or equal to our force of friction, right? So I'm looking at f cosine theta. Oh, wait a minute. Oh, yeah, we're good, sorry. It has to be greater than or equal to 54 minus 0.3 sine theta f. And we're trying to come up with an expression for f as a function of theta. So we just got to solve for f. So we got to move our f's to the other side. So let's add this to both sides. So now we're going to have f cosine theta plus 0.3 sine theta f is bigger than or equal to 54. Oops. 54, factor out an f, and now we've got cosine theta plus 0.3 sine theta is bigger than or equal to 54. So then divide both sides, and you get f has to be bigger or equal than 54 over cosine theta plus 0.3 sine theta. Okay. All right, and then finally, the last question then, what does the last question say? Determine the value of theta for which f is a minimum, and then find that minimum magnitude. All right, so what we need to do is we want to minimize the value of this function. So we got to figure out, so that function is, if you graph f versus theta, it's going to give you some kind of function that looks, I don't know, something like this or whatever, and we need to find this point. So we need to find the point at which the derivative of the force as a function of theta is 0, right? So that we're finding that minimum point. Okay, so we got to take the derivative of this mess. So some of you guys may not have learned this yet. I think we got to use the quotient rule. So I'm going to pause my recording. All right, so I always forget the quotient rule. Honestly, I have to look it up every time. There's like a Heidi, Lodi, Heidi, something. But so I just looked it up. And so it's the bottom times the derivative of the top. So I'm going to do the bottom times the derivative of the top. So that's going to give me, this mess, but the derivative of the top is 0. Okay, minus the top times the derivative of the bottom. So that one I actually got to figure out. So that's going to be 54 times the derivative of the bottom. Well, the derivative of cosine is it sine or negative sine? It's a negative sine. So this is negative sine theta plus 0.3 times the derivative of sine is just cosine all over the bottom squared. And then set it equal to 0. Well, if my fraction here equals 0, that means that the top has to equal 0. And the only way that's going to happen is if this is equal to 0. So we've got negative sine theta plus 0.3 cosine theta equals 0. So 0.3 cosine theta equals sine theta. Divide both sides by cosine. Sine over cosine is tangent. So now we can solve for our angle. inverse tangent of 0.3, which is like 16.7 degrees. Okay, and so now we got to go back and find that force, which we can get. Oh, to find the corresponding force, we can plug it in here. So 54 divided by, in parentheses, the cosine of that number plus 0.3 times the sine of that number. And it gives us 51.7 newtons. All right, so there we go.